I don't know if you can see me now or not. uh, can you see me?
Yeah, I think turning on your video made your internet really like it messed up your sound. So you might want to turn your video off.
Yeah, okay. I'm gonna start here.
Yeah, it's better.
Array index and element equality.
Okay.
Given a sorted array R of distinct integers, write a function index equals value search that returns the lowest index I for each array y equal I. Return -1 if there is no such index. Analyze the time and space complexities of your solution and explain its correctness. For example, I have -8025, output is 2, because the element itself, the value is equal to the index. And here we have -1036, since no index in array equal to its index. Okay, I'm gonna print -1. Given a sorted array of distinct integers, write a function that returns the lowest index for each array. Okay, so I'll be given an array, and I think I got the problem. uh, I'll be given an array and I should return the should I return the index or the they are the same. So I'll be given an array like this, and I should return the first element, which is index equal to the value itself. Is that right?
Yes.
Like here, the index of this element is 0, they are not equal. Here it's 1, they are not equal. It's 2, and they are equal. So I'm gonna return 2. I guess
Yep.
like the brute force approach, or the approach that comes to my mind, is just iterate over the loop, and when the element from the beginning till the end, when the element itself is equal to the index, I will return this element, and that's it. uh, so this is the approach, and the time space will be O of n, and the space will be O of 1, because I'm not using any other data structure. Is that right? Like,
Yeah.
should I use like, is there any optimization should I do, or is that it?
No. So that your brute force works and it would be linear time, but the question then is, can you improve upon that brute force to do it in a better time complexity?
Okay, okay, so the brute force only the time complexity is open.
Mhm.
Okay, we know that the array is sorted. From here we can just think of using a binary search, uh, because it would be helpful here. Okay, so how we're gonna use it here? uh, if we have this array, now if low equals 0, high is equal to n negative n minus 1, which is 0, 1, 2, 3, and mid is equal to 1. So now I'm here, and now I'm gonna compare the arrow of mid, which is 0, to its index, and I see that this element is not equal its index. So I should move to I should move to a specific side, to the left or to the right, but I should uh, think that now. uh, Here we know okay, let me, these are the indices. Okay, now we know that this element is not equal its index. If I go to the right, uh, but I see that the element itself is less than the the actual index, so there's a possibility to have an answer, so I'm gonna go to the right in this case.
Mm-hmm.
So after that, the to go to the right, the gonna change the low to be mid plus 1, which is equal to 2. Now here, this is a mid, and I'm gonna compare it to its index. I see that the element is equal to the index, so that's a good job. Here we have an answer, and I will store it in a variable like minimum array index element. I'm just trying to think of a good variable, a good name variable. Okay, for now I can call it minimum answer. It would be 2. From here I should go to the left to see if I have any other if I have any other value its index equal to it, because it's saying that you should return the lowest index. So I'm gonna go to the left, but we see that I can't go to the left, so that's it. I will return this answer. So this would be my approach, but let me just test write another test case. Okay, if I have this, the mid, now low is equal 0, high is equal 3, and mid is equal 1. So now I'm gonna compare this element to its value, to its index. We see that it is not equal, so I should go to the right, and when I'm gonna go to the right, I see that 3 is less than 3 is not equal to the index, but 3 is bigger than its index, so I should go to the left in this case. So this is a good a good thing to think about. If the element itself is less than its index, in this case I'm gonna go to the right, but if the element itself its value is bigger than it's bigger than its index, I'm gonna go to the right. So this would be my approach. Should I code this approach? But by the way, the time complexity of the binary search would be O of log n, and the space is O of 1 because I'm not using any other data structures.
Yeah, it sounds good.
Great. Okay, I'm gonna code it out. Okay, in the beginning I will have int n equal r dot size, and then let's make int l equal 0 and h equal n -1 and mid, and here we have while l less than h, so mid is equal to l plus h over 2. After that I'm comparing if r of mid is equal to its index, which is mid. In this case I know I have an answer, so let's make int answer equal to int max, but minimum answer, yeah, gonna sort the, we can say lowest index. I'm just trying to get a good name. In this case, lowest index will equal to mid, the minimum between lowest index and mid. In this case, okay, so what if the element r of mid x bigger than its index, and okay, if the element itself is bigger than the index, we said that we're gonna go to the right, so high will equal to mid minus 1, and here if arrow of mid, oh, just yeah, and here if the variable or if the element itself is less than its index, we said we're gonna go to the right, so L will equal to mid plus 1, and okay. Okay. In the end, I should return the answer, but if I don't have any answer, I'm gonna return -1. So I'm gonna make a condition here. If okay, if lowest index is equal to int max, which means that it is not reinitialized with any other variables, so it would be I'm gonna return -1, otherwise I'm gonna return lowest index. So this is my answer. Let me go through the code. Are you there?
Yeah.
Okay, so here I'm having that size L equal 0, H equal N negative N minus 1, mid, okay, and lowest index is my answer, while L is less than H, mid equal, okay, if they are equal, I have lowest. But here I think I should do something. Okay, now I have the answer, but I should determine the direction. We said before if they are equal, so we can go to the left. Go to the left. So in this case, H is equal to mid minus 1, and here if the element itself is bigger than the element itself bigger than its index, I'm gonna go to the left. Yeah. Okay, here and here. So lowest index is equal to int max. Yeah. I'm gonna run my code and use a test case.
Okay.
Okay. Okay. So here, vector and test 1 is equal to okay. So cout then we will have test 2. We can say test 1 is equal to this. Yeah, I'm gonna run the code.
Okay.
To -1, which is the actual output. I'm gonna run the test cases.
I'm gonna say, what if you have an array of length 1? Does that work?
Sorry, I couldn't hear you well.
Yeah, if your input array is like length 1.
Okay, if has just, for example, 1.
Yeah.
Okay, here mid will equal to L plus plus H over 2, which is 0. Okay, and here I'm checking. Okay, they are not equal, so the index itself is equal to 0. I see that the element is bigger than the index, so H will equal to mid -1, which is equal to -1. So here we will have L equal 0 and H equal -1. When I'm gonna go here again, we will see that low is not less than H, so I'm gonna break this loop. So
Okay.
so it's working.
Okay, you can run the test if you want.
Okay. Oh. What is the problem? For the first test case, we have 0. The actual is -1. Okay. If I have 0, if arrow of mid. Okay. If arrow of mid. Oh, I think it should be L less than or equal.
Mm-hmm.
Yeah. Oh God. Yeah.
Cool.
Is there anything else I should do to my approach or my code?
It's pretty good. I think the one minor thing that you could have done was, depending on how you do your plus and minus, you could just check the value at the last index for this mid. If you just check this L, and then you can just see if it matches or not, and then you don't have to worry about doing it this way. You could just check the L against the input array, and if those match, then that would be your solution.
I think I got your point. Yeah.
Yeah, that's the only improvement really that you can make. Well, and I think then you also could move this. So it's just like one if and else. So it's always either this and this are kind of the same thing.
You're right.
But yeah, I mean, it's minor. You got the right solution and the right runtime. If you wanted the minor code optimizations, that was all.
Yeah, I think I'm gonna optimize it after this session.
But yeah, the rest of it was good, and the dry run was good and everything.
Do you have any other comments on my code or my way of thinking on all this stuff?
No, I think your thought process was clear, and I think you ran through the examples well, and then you coded it up pretty clearly and made sure that you had the test cases well covered. I think that's kind of why I was trying to give you the idea of one array, because I kind of saw that the lesson was going to fail, but you kind of skipped down to this part and did kind of catch that this wasn't going to be set up the first time, which is minor. You caught it after running the test. But just a minor thing to keep in mind, I guess, of edge cases. But yeah, everything else was good and clear.
Yeah, thank you so much.